Hello guys, welcome to another episode of this tutorial. In the last episode we talked about first law of thermodynamics and the steady flow energy equation and their practical applications. And we also solved problems and tackled some questions. So in this tutorial we'll be looking at the working fluid and the use of steam table. So before then, there are some parameters we should know because we'll be using more of them in solving questions, and they are the dryness fraction, the wetness fraction, and also the surfaces. Okay, yes, the surfaces. So dryness fraction, which is denoted by X, is the mass of dry vapor in 1 kilogram of the mixture. Is in 1 kilogram of the mixture. So wetness fraction, on the other hand, which is denoted by the letter Y, is the mass of liquid in 1 kilogram of the mixture. You can also say Y is equal to 1 minus X. That is when the dryness fraction subtracted from 1, you have what we call the wetness fraction. So also for a dry saturated vapor, the dryness fraction is equal to 1. And also for a saturated liquid, the dryness fraction is 0. So we need to know all these things so that while solving questions, it might be hidden, it might be written in a corny way. So if you are unable to decipher or be able to understand what the question is talking about, you won't be able to solve it correctly. So let's go down to some equations we are going to use here. So the use of vapor tables. Now the G surface is used to denote the dry saturated stage, while that is the gas, and the F surface is used to denote saturated liquid stage. So specific volume now, specific volume, I will say specific volume, specific volume. Now let me use another color to do this. Okay, let's use another color. So let's use so specific volume, specific volume, which is the small letter v, is equal to 1 minus x. You know what x is already? Vf. This is volume of liquid, plus x, volume of saturated gas. So specific enthalpy, specific enthalpy, specific enthalpy will be enthalpy, small letter h2, will be equal to same thing, 1 minus x hf subscript f plus x hg. Okay, now same thing goes, but we can also change this formula to h can also be written as hf plus x hg minus hf. So this will give us hf plus what? X hf g. Okay, yes, that's what we have there. So at the end of the day, we have this. So we'll go over to specific entropy. Specific entropy, that's a small s, just like specific enthalpy. Let's go straight to the final formula. We have SFG. Okay, yes, the next one, which is the last one, is the specific internal energy. The specific internal energy, that is U, which is equal to UF plus X UG minus UF. You know what G and F is. So these formulas are what we are going to use to solve the problems in this particular tutorial video. So let's take an example. Let's take an example to be able to illustrate how this is being used. So I'll take a question now. That should be yes. Example 1. It said calculate the dryness fraction, specific volume and specific internal energy of the steam at 7 bar and specific enthalpy, given that the specific enthalpy is 2600 kilojoule per kilogram. So this is a simple one. You start by detailing your parameters. So solution, okay, parameters given, what are the parameters given here? Parameters are the pressure P, 7 bar, the specific enthalpy, that is small h, is given as 2600 kilojoule per kilogram. Now we are told to calculate the dryness fraction, and recall that from the formula we just derived, or formula we stated in the other page, specific enthalpy is given as HF plus X HFG. But what is the meaning of HF and HFG? So from the steam table, if you have a steam table, you can download it, or you can get it from a shop, maybe shop. So the steam table, we have this value from the steam table. So the pressure P, okay, pressure P, we rule a line, we have the VG, what I call it, okay, let's write the TS, saturated temperature, we rule a line too. Now VG, we have a VG, we also rule a line. Now we have our have our UF, you roll a line to. We have a UG, that is energy of the gas specific. And we have our HF, we roll a line to. We have our HLG, we roll a line. So we roll a line, and that's it. Now this SI unit for this is bar, SI unit for this is degree C, SI unit for this is meter cube per kilogram. The SI unit for this is kilojoule per kilogram. SI unit for this is remains the same, per kilogram, the same, kilojoule per kilogram. Alright, now 7 bar, at 7 bar on the same table. Why I'm writing this thing is because of, or for the sake of those that don't have the steam table, so that you'll be able to flow with the tutorial. Okay, so 696 here is 2573. Okay, we have here to be H, yes, 697, here is what, 2067. So these are the values on the steam table. So we can come here and write from the saturated steam table, or from saturated steam table, we have this. Okay, so we are told to find the dryness fraction. Okay, so that should not be a problem. That shouldn't be a problem, because H is equal to what? HF plus X, HLG, and H was given to us as 2600. What is HF? What is HF? HF is 697 plus, we don't know the dryness fraction, and HFG is 2067. Okay, you do your necessary mathematics. Here you have this, so finally X will be equal to 1903 all over 2067, which is equal to 0.921. Now we have gotten the dryness fraction, so we can say dryness fraction, our dryness fraction X is equal to 0.921. Now second one is the specific volume. Okay, the specific volume V, the small letter v, is our formula Vf plus X Vg. But the value of Vf, that is volume of saturated liquid, is very small. So you can be assumed to be negligible in most cases, unless if it's given. So in this case, we can say Vf is negligible because it's very, very, very small. So as little as it can be, this formula shortens to xvg. So v now will be equal to, you know what vg is from the table. vg is 0.2728. now that means specific volume now will be equal to 0.2512 meter cube per kilogram. Don't forget your SI unit, very important. So we have gotten the dryness fraction, specific volume. The next is specific internal energy. Yes, specific internal energy. Yes, that also can be denoted by this, which is 1 minus x uf minus plus x ug. Alright, yes, that's what we have here. So it can also be written as uf, that is, if you collect some terms, you have the uf plus x ug minus uf, close the bracket. So specific internal energy will be, know the value of uf from the table. And what is it? 696 plus, you know, our dryness fraction, you know, our ug. Our ug is 2573 minus uf. What is our uf? 6962. So calculating this, we get that this becomes 1877. So finally 2424.72 kilojoule per kilogram. That's our answer. So guys, you can see that it's not difficult. Yes, it's not difficult at all. It's all about knowing how to read out your values from the steam table and carefully substituting them into the rightful formula, and your answer is there and out. Okay, so they could actually ask you a question in a way that the pressure or the stated pressure or the stated property that you are supposed to find is not in the steam table. So in that situation, you interpolate. Interpolation is actually finding the unknown in between two known values. So how do we do this? Are you confused? Let's take an example.
It need to lick on some ladies. Yeah, we did turn up on a daily. It's how I walk up. Yeah, soft walk.